Assalamu alaikum, everyone. Welcome to Mathematics with Shahab Yaqub. Now, in this particular video, we'll be solving this particular question, October-November 2021, variant 63, and this is for S2, paper 6 probability in S2. And it's a walkthrough video. So let's get started. The time is 3:22. Of course, we cannot be very sure how much time it took, but usually an S2 paper takes around like 45-50 minutes. Now let's look at the first thing. It says, it is known that the height h meters of trees of a certain kind has the distribution normal 12.5, 10.24. A scientist takes a random sample of 25 trees, find the sample mean h bar of the height, state the distribution of h bar giving values of any parameters. So first of all, h bar follows the normal distribution. The mean remains as it is. The variance is divided by number of sample. You can write it like this. After writing it like this, also write it like this. Expectation is the mean. Variance is mean divided by n. Since calculation is involved, go ahead and calculate it. If it's exact, leave the answer as it is. Second part, find the probability h bar lies between two values. So h bar lies between 12 and 13, standardize. Subtract the mean, divide by the new variance, which is variance divided by n, square root. Don't forget that. Now this is 0.5 units away. This is 0.5 units away. This is coming out to be negative. This is coming out to be positive. Rule number 7. Phi of this value plus phi of this value, that is reading the probability from the table and then subtract 1. This is the answer. Correct to 3 SF. So now this is 2 and 3, 5-mark question. I think 5 minutes are more than enough for this one. Question number 2. It says the number of inquiries received per day at a customer service desk has a Poisson distribution with mean 45.2. If more than 60 inquiries are received, the customer service desk cannot deal with them all. So this is like the condition. Customer service desk cannot deal with them all. Use a suitable approximation. It's already Poisson. Find the probability that on a randomly chosen day, it's about a day, the customer service desk cannot deal with all the inquiries. That is the mean number of occurrences. Since lambda is greater than 15, what do? We convert it into normal distribution. So x follows a normal distribution, 45.2, 45.2. We are looking for greater than 60 continuity correction. 60 is not inclusive. Choose the upper bound, that is 60.5. Once you have chosen 60.5, standardize. You get this z value. Z is greater than this value. That is the normal distribution gives you the lesser value. For greater, subtract it from 1. Read the probability, subtract from 1. That is the answer. Another basic question for 4 marks, maximum 4 minutes. Question number 3. It says a random sample of 75 students from a large college was selected for a survey. 15 of these students said that they owned a car. From this result, an approximate alpha % confidence interval for the population, for the proportion of all students at the college who own a car was calculated. So we are talking about population proportion confidence interval. The width is found to be 0.162. Calculate the value of alpha, correct to 2 SF. Now, first of all, what needs to be done is that 15 out of 75, that is your proportion of success. Proportion of failure, 1 minus proportion of success. N comes out to be 75, given as 75. The width formula, 2z square root PS QS over N. That is the width, that is PS, that is QS, that is N. We find the value of Z, 1.754. Now, don't be in a hurry. 1.754 is the Z value over here. There is also negative 1.754. Left of 1.754 is 96%, right as 4%. Right as 4%, left as 4%. How much is left? 92%. That is the level of confidence interval. It's given correct to 2SF. That was slightly more conceptual. 5-mark question. Question number 4, CRV, continuous random variable. So now it says a random variable X has the PDF probability distribution function or density function given by This is the quadratic function, and it lies between 0 and 3. Find the probability, first part, x is lesser than 1.2. That is, this is 0, this is 3, the total probability is 1, but they are asking for less than 1.2. That means 1.2 is the upper limit, 0 is the lower limit. Integrate the function, that is 9x minus x cube over 3. Plug in the upper limit, plug in the lower limit. So that was in blue color. Let me highlight it. And once this is done, this comes out to be this particular value. Let me highlight 0.568 or 75 over 125. It's your choice in which a unit you want to give it. If it's exact, leave it as it is. If rounding off is needed, then 3 SF unless otherwise stated. Find expectation of x. So expectation of x is what? That is 1 over 18. That is the constant. First of all, what we do is that we write between these two limits. That is 0 and 3. And what else is there? You have to multiply it with x. So this is 9x minus x cubed, and then integrate it. So 9x minus x cubed integrated each term. That is 9x squared over 2. That is x4 over 4. Plug in the limits, and you get this answer 1.125. So now this thing is also done. The next one, the median of x is m. Show that this equation is true. Now, what is median? When we talk about cumulative frequency, the 50% of cumulative frequency gives us a value, that's the median. That means 50% of the distribution lies below median, 50% lies above it. So probability x lesser than m is 0.5. Integrate the function, m becomes the upper limit, 0 becomes the lower limit, equal at 2.5. So now this integration is done. Once the integration is done, this is the upper limit, this is the lower limit, 0 gives us 0. That's very comforting. And we have this equation. How did we get a 9 over here? I took 1 over 18 to the other side, multiplied it with 0.5. We get this thing, multiply throughout by 3, and we get this cubic equation, which is n cubed minus 27m plus 27 equals to 0. We don't have to solve it. Question 5. The proportion of people having a particular medical condition is 1 in 100,000. A random sample of 2,500 people is obtained. This is binomial. X follows a binomial distribution. This is number of trials. This is probability of success. The number of people in the sample having this condition is denoted by X. State with a justification a suitable approximating distribution for X giving the values of any parameters. So N is this thing, P is this thing, NP is this thing. Since N is greater than or equal to 50, NP is lesser than 5. That is the justification. X follows a Poisson distribution with such and such. So now the mean is this. So that is the justification, and that is how it's converted to Poisson. Use the approximating distribution. Find the probability X is greater than 0. Greater than 0 does not include 0. It includes 1, 2, all the way till infinity. So since you need all of them, just subtract the probability of 0. This is e raised to power of negative lambda, lambda power 0 over 0 factorial. This is 1. So this is e raised to power of negative lambda, subtract from 1. And this is the answer that you are getting. All good, all clear? Question, the same question, part B. Now it says the percentage of people having different medical condition is thought to be 30%. A researcher suspects, it's always about suspicion, that the true percentage is less. In a medical trial, a random sample of 28 people was selected and 4 people were found to have this condition. Use a binomial distribution to test the researcher's suspicion at the 2% significance level. Now, first thing first, state the distribution. This 28 goes over here. This 30% goes over here. This 4 is the sample value. H0 P is 30%. H1 P is less than 30%. That is the suspicion, less than 30%. 2% significance level. Sample value is 4. That is by default inclusive. You have to calculate probability in this direction. Probability x is lesser than or equal to 4. Let me fill in the values. So that is 28C4. Success. This is 0.3. This is 0.3. This is 0.3. Let me write it down. This is 0.3 raised to power of 4, 3, 2, 1, 0. And probability of failure 0.7 all along, 0.7, 0.7, 0.7 raised to power of 28 minus 4 is 24, and then 25, and then 26, and then 27, and then 28. So now we calculate all this thing, and this comes out to be how much? This comes out to be 0.0474, which is 4.74%. Let me write it properly. So this is 4.74%. For hypothesis, always convert it into percentage. Now let's compare 4.74%. Is it lesser than the significance level? The answer is no. So therefore, do not reject H0, accept H0. There is insufficient evidence that the suspicion is true. We cannot accept the suspicion because we don't have enough evidence at the significance level. So this is question number 5. I think that's done. Question number 6. The random variable t denotes the time in seconds for 100-meter races by Tanya. T is normally distributed with mean mu and variance sigma square. What is t? T is the time by Tanya. A random sample of 40 races run by Tanya gave the following result. N is this, sigma t is this, sigma t square is this. Calculate unbiased estimate of mean and variance. So first of all, what we do, we calculate the sample mean, which is t bar. We calculate sample variance, which no need to evaluate, leave it as it is. Let me just adjust this thing. That is as it is. Then what do? Then we calculate this thing, that unbiased estimate of population mean is the same thing as sample mean. Unbiased estimate of population variance, it's n over n minus 1 sample variance, and this is the rounded off value. That's how this particular thing is done. Next part, the random variable S denotes the time in seconds for 100-meter races by Suki. S has the independent distribution such and such. Using your answer to part A, find the probability in a randomly chosen race. Suki's time will be at least 0.1 seconds more than Tanya's time. So this is the distribution for Suki. So let me just highlight this. This is for Suki. This is for Tanya. And Suki minus Tanya. So this is Tanya. This is Suki. The difference is at least 0.1. Now, X follows a normal distribution, but that will come later on. First of all, X is S minus T. So what is expectation? We take Suki's 14.2, we take 14 and subtract 14.2 minus 14, that is 0.2. And what about the variances? We add it up. That I have written it separately. So therefore, X now follows a normal distribution such and such, and then probability X is greater than 0.1. Probability Z is greater than 0.1 minus 0.2 divided by square root of variance. That is negative 0.134. Flip the inequality, remove the negative sign. This is direct reading, and that is the answer for this particular part. So that is question number 6 is done and dusted. Now comes the last question. That is this thing. The masses of apples from a certain farm have a mean mu and standard deviations 5.2. The farmer says the value of mu is 64.6. A quality control inspector claims, it's either suspicion or claim, that the value of mu is actually less than 64.6. In order to test this claim, he chooses a random sample of 100 apples from the farm. So we have standard deviation, we have 64.6, that is the usual standard. The quality control inspector claims it's lesser, it's a one-tail, lower tail test, 100 is the value of n. The mean mass of 100 apple is 63.5, that is sample mean. Test the carry out the test at the 2.5% significance level. So X bar follows a normal distribution, that is mu. that is sigma square over n. Sample mean is 63.5. So this is the sample mean, 63.5. H naught mu is 64.6. H1 mu is lesser than 64.6, 2.5% significance level. Now we calculate Z, and Z is coming out to be negative 2.115. It's a lower tail test. It's normal distribution. For 2.5%, this is the corresponding Z value. That is the critical region. That is the rejection region. What about the Z calculated value? Does it lie inside the critical region? Yes, Z value lies inside critical region. Because this is 0, this is negative 1.96, negative 2, negative 2 point something, 115. It lies inside critical region. Therefore, reject H naught, accept H1. Yes, we have sufficient evidence at the 2.5% significance level to accept quality control inspector's claim. Now, the next one. This is also very important, 5 marks out of a 50-mark paper. Later, another test of the same hypothesis at the 2.5% significance level with another random sample of 100 apples from the same farm is carried out. Given that the value of mu is 62.7, calculate the probability of type 2 error. So now, in order for calculation of type 2 error, I need the critical region. Type 2 is related with acceptance region. Type 1 is related with critical region or rejection region. So first step 1 is to calculate rejection region for this test. That means, let me just illustrate it further. Let me just reduce it. It's a lower tail test for the same significance level. So this is 2.5% significance level and the Z value is 1.96. That means if Z is inside the critical region, that means Z is lesser than or equal to 1.96. We would reject H naught in favor of H1. This is the critical region. So what is Z? We need to find this boundary condition. What is the X bar value? So X bar minus 64.6 divided by variance over n square root is lesser than or equal to negative 1.96. We find that X bar is lesser than or equal to 63 point this thing. This is critical region. For type 2, we need acceptance region. That is why the inequality is flipped. And for type 2, we use the new value of mu. So now X bar is greater than 63 point this thing. XZ is lesser than 63 minus 62.7 divided by this whole thing. Z is greater than 1.694. This is rule number 2. We need the greater region. Read the probability for lesser, subtract it from 1, and then we get this answer. This answer is this much. That's the probability of type 2 error. So that was this paper of S2. And we started at, I think I forgot the time. So no issue. This was a short video because it was a walkthrough video. So stay tuned for more content on mathematics with Shahab Yaqub.